Welcome to our lesson on integration of trigonometric functions. First, as always, remember that integration is the opposite of differentiation. So let's review some basic trig derivatives and their corresponding indefinite integrals. So remember that the derivative of sine is cosine, right? So that means then that the integral of cosine is sine plus c. What was the derivative of cosine? It was negative sine. So then that means that the integral of sine is negative cosine, of course, plus c. And then the rest, you're not really required to know, but I'll just mention one of them. Remember, we had seen that the derivative of the tangent function is indeed secant squared. So then that means that the integral of secant squared would be the tangent function plus a constant. Side note, normally in calculus, angles are measured in radians. However, since that is a topic that we will get to when we do the topic of trigonometry later on, for now, we will continue working in degrees. We will review integration when we get to trigonometry as a strategy to keep things fresh in our minds. So remember that for the future. So let's get into an example. Let's say you are to evaluate the integral from 30 up to 45 degrees of cosine of x with respect to x. So first thing, you will need to know what we call the exact trig values. So here in this table, that's where you will get those, all right? These will be given to you. You don't have to memorize these. So these are readily available on the internet, and so it is readily available to you as well. Just use the table to get the exact trig values. And by exact trig values, we mean not a decimal rounded off to 3 decimal place or to 5 decimal place or anything like that, but in terms of fractions, whole numbers, and square roots, also known as surds. So our problem is to find the integral from 30 up to 45 degrees of the cosine of x with respect to x. So first off, what's the derivative of sine? It's cosine. So that means the integral of cosine is sine. So we're going to evaluate this when it is 45 degrees and 30 degrees and subtract. So the sine of 45 degrees minus the sine of 30 degrees. From our table, we see here that the sine of 45 degrees is root 2 over 2. And then the sine of 30 degrees is 1 over 2 or a half. Here, this example for us is easy because all we need to do is to keep that common denominator and then just subtract the numerators. So for us, fortunately, square root of 2 minus 1 does not simplify. You just leave it as root 2 minus 1 all over 2. Next, we're going to step it up a little bit. Here, if you're going to multiply multiples of the sine or cosine function, there's a couple formulae we need to know. If you are trying to integrate a times the sine of px, then that will be equal to the negative a over p of the cosine of px plus c in general. And similarly, for cosine, it is a over p times the sine of px plus a constant. So let's look at an example. Let's say we are to evaluate the integral from 0 up to 60 degrees of 2 cosine 4x plus 3 sine 3x with respect to x. Our integral, let's see how it works out. We have to integrate 2 times the cosine of 4x. So using our formula, it should be 2 over 4. So that reduces to 1/2. So you have 1/2 times the sine of 4x. Then when it comes to the integration of sine, the integral of sine is negative. Then 3 over 3 is 1. So that's why there is no number written here, but it's understood to be negative 1. And then it will be the cosine of 3x. So we will evaluate when x is 0 and when x is 60 degrees. So substituting those values, we'll have 4 times 60, 3 times 60, 4 times 0, and 3 times 0. So 4 times 60 is 240. 3 times 60 is 180. And of course, 4 times 0 is 0. Now, next, finding the sine of 240 degrees. Using your calculator, the sine of 240 is 0.866. Negative 0.866 to be precise. So 1/2 of negative 0.866 will give you negative 0.433. Also, using your calculator, the cosine of 180 degrees is -1. The sine of 0 is 0, and the cosine of 0 is 1. Next, you have to be careful when evaluating these type of problems. Be careful with your signs, the positive and negatives. So when we expand our brackets, when we remove brackets, then we'll have -0.433 plus 1, take away 0 plus 1. So 1 plus 1 is 2, and then 2 take away 0.433 leaves us with 1.567. So that is your answer. When working out problems like these, you have to be careful with your positive and negative signs. For most of you, that may be where you might lose marks. Also, I just want to note that technically, there is the exact value for the sine of 240 degrees and for the cosine of 180 degrees that you can get without the use of your calculator. The exact value of the sine of 240 degrees is actually the -√3/2. But I won't test you girls on that just yet, because like I said earlier, in this lesson, we have not gotten to trigonometry yet. So when we get to trigonometry, then you will be shown how to get the exact trig value of a multitude of numbers from 0 degrees up to 360 degrees, not only from 0 to 90. When it comes to the angles between 0 and 90 degrees, since I will provide you with that particular table, then you will be required to have the exact trig values for those. But so long as it is greater than 90 degrees, then I will leave it to just using your calculator and giving the decimal value to 3 decimal places. So in summary, eat, sleep, math, repeat.